so cool!
Pretty awesome, huh? It's the new rubber band gun.
Mom, I want one. Can we get it? Wait a minute, I'm not so sure. How does it work?
Well, when the rubber band is pulled from the end of the gun to the spokes, it creates elastic potential energy. Then the trigger is pulled, and elastic potential energy is transferred to kinetic energy as the rubber band flies through the air.
Whoa, how fast can it go?
Well, when it is pulled to the spokes, the rubber band is stretched 0.107 meters. The force needed to stretch it this distance is 4.6 newtons. By taking half the force times the distance, we can find the elastic potential energy to be 0.246 joules. Because energy can neither be created nor destroyed, there must be 0.246 joules of kinetic energy as well. We found the mass of the rubber band to be 0.001 kilograms. So by taking the square root of the kinetic energy divided by 1/2 the mass, we found the velocity of the rubber band to be 22.19 meters per second.
Wait a minute, isn't some of that elastic potential energy lost to heat?
Well, yes, so we found the real velocity by measuring the time it took the band to travel 0.015 meters. This time turned out to be 0.002842 seconds, which made the velocity 5.278 meters per second. We squared this number and multiplied it by 1/2 the mass and found that the kinetic energy was actually 0.0139 joules. To find the heat loss, we subtracted this from the original EPE and found that 0.2321 joules of energy were lost to heat because of friction.
Well, that's great and all, but you could have made a few mistakes in your experiments. You may have only done one trial for the actual velocity. You may have used different rubber bands to calculate EPE and KE, which may have led to variations in the rubber bands. Of course, there could have been human error in stretching the rubber bands with the force sensors or in your calculations.
Look, lady, you want to buy it or not?
Alright, honey, would you like one?
Never mind, Mom.